Yo everyone, JC here. How's it going? Hope everyone's doing well. Now, like I posted a few days ago on my page, I wanted to dedicate the month of August to the issue of climate change. The reason is, well, obviously because, yeah, it's a serious issue. And also because a few years ago now, I made an online course on climate change and I'd like to kind of promote it as well. Like I will post articles, of course, and you can, go ahead and read those articles. It's not just about don't read just the headline because that is absolutely useless. Go and actually read the articles because you need to know the details. If you don't know the details and all you know is the headline, that will not get you very far, to be honest, or not far at all, actually. So yeah, check out my course. It's a great course. It's about 15 lectures. And look, I'm not like a scientist, but I do communicate to scientists from time to time. And in general, I consider myself quite well versed, quite well, quite well versed. Not easy to pronounce that one because a lot of V's and W's in the topic. So yeah, check it out. It's absolutely for free. It's on YouTube. So yeah, you're not paying anything. There's no ads, as far as I'm aware, anyway. And check it out. It's a great course. You'll learn a lot, and it's very easy to understand. Like it's pretty much chewed and digested for you. So all you have to do is just watch it. But I will also say, don't just accept everything at face value. Go ahead and check out, double check the information for yourself. At the time I made the course, I used the best information available for me at the time. But look, it's science, and science always moves forward, and there's always new stuff coming in, new evidence, new data coming in. If you have computer simulations, then the computers are getting better, more powerful, and so we can get more accurate predictions and stuff like that. So just be aware of that. But I would say that overall, still, my course is still pretty much up to date. Maybe there's a few things here and there that should be amended, but overall, yeah, it's still pretty much the same thing. I am a bit wary talking about this topic to audiences in the States. To be honest with you, I also don't know much about audiences abroad, but I know that in the States we have a lot of not just climate deniers, but science deniers in general. I mean, even things like this, which is, a simple mask, apparently this is too much to ask for some people. Even this is too fucking hard. So, what do you expect then when we talk about something complex as climate change? Do you really think that those people are gonna, understand the science? Do you really think that they're gonna change their behaviors to make the problem better? Because at the end of the day, we have to change our behaviors, whether we like it or not. I mean, first of all, there's 8 billion people on Earth, okay, and everybody basically wants to live the American dream. So everybody wants a house, everybody wants at least one car. They want a bunch of appliances in the house, AC, fridge, you name it, and all of that creates emissions. And as you can imagine, as more and more people move out of poverty into the middle class, they're going to buy more and more shit. So yes, of course I understand that, yes, there are very dirty factories out there polluting the world much more, for example, than me as an individual. And that is true. But those industries produce things that even I use as an individual, and eventually it all accumulates. So you talk about the power generators, they use a lot of CO2 because it comes from coal, it comes from gas, etc., etc., and all of that is fossil fuel. So you're talking about some kind of cheap plastic crap from China. Well, guess what? That's emissions. And on top of that, you also need to transport all that shit. and it's not just by trucks, but it's also by airplanes, etc. You get the idea. It's very all of that is a very polluting environment. And yes, eventually, what I advocate for is that we need to start living a bit more like minimalistic, like buy less shit. Like like I always see these kind of things, especially on Black Friday. There are those videos on YouTube, like every year, the doors to the mall open, and this mob. That's where the zombie franchise came from, by the way. I'm pretty sure, because this mob just kind of rolls into the mall like a tsunami, and they start like fighting each other for like DVD players and Blu-ray players and TVs and stuff like that. And I'm watching that, and I'm thinking like, oh my god, like this just honestly makes me ashamed to be called a human being, because yeah, one of them as well. But man, but anyway, yeah, what I would suggest is just go ahead and get as much information as you want. Don't just listen to some kind of, fossil fuel talking points and just accept it at face value, because that is the worst thing you can do. Go ahead and actually investigate things. Now, I also know that if you start investigating and you don't know what to investigate, you're gonna end up on Google, and you're gonna find articles like, actually it's not global warming, but it's global cooling, and you're gonna find a lot of articles like that, and on YouTube as well. And if you click on one of them, if you watch one of those, it's gonna recommend to you similar videos. So you're gonna think maybe to yourself, oh wow, look, there's a lot of evidence um, pointing to the opposite of what you know the actual scientists are saying. So maybe the actual scientists are wrong, but it's not like that. Of course, you're just watching a bunch of misinformation. So let me jump into my graph here. Let me close that. That's from my mouse. So I collect temperatures in Japan for the past 7 years. I think it's 7 years, but let me double check. 1, 2, 3, 4. Yeah, it's about 7 years. And mostly I do that actually for fun. I mean, I'm not getting paid for it. It's trust me, I'm not like paid by the science or paid by the government. Okay, I'm not. I all I have is two thermometers sitting on my balcony, and I take the temperature every day at 1 o'clock in the morning. Uh, so one question you might have is, why 1 o'clock in the morning? Well, the reason is because usually when temperatures are measured, right? Usually it's taken during the day. And that's why when they talk about some kind of heat wave and stuff like that, usually the temperatures you see are kind of at the peak of the temperature during that day. So usually typically I'm not sure exactly when that is. Is it at noon, or maybe shortly after noon, when the temperatures reach their peak? And after that, when the sun starts to set, the temperatures typically start to decline. And of course, then you go into the night and they decline even further. That's just how it goes. But I wanted to, well, I don't want to do the same, If I do the same, it's kind of pointless, because there's already lots and lots of research taken during the daytime. So I thought, okay, let's go for 1 a.m., because 1 a.m. is actually kind of a good spot. It's a time where the cooling has begun, but it hasn't cooled down all the way. Usually, I would say the peak cooling is before the sun rises, but that's typically like 5 a.m. or 6 a.m. It depends, of course, on the time zone and stuff like that. But I wanted to go kind of in the middle and see how it goes. So for the past 7 years, I've been measuring temperatures every day. This part here. So what you're looking at here is the temperatures per month per year. Okay, so this is kind of like the monthly averages every month per every year, going back 6 years ago to 2017. And this graph is interesting because, yeah, I mean, you can compare the temperatures here. I mean, because it's by month, so you can definitely like look at which month was the hottest so far, etc., etc. If you look at, for example, the months of June and July, you'll notice that if you compare them all, this last cycle, which for me goes from July 31st to July 31st every year, June and July are the hottest I have on record. And this is not very surprising. If you've been paying attention to the news recently, you probably read a lot that July was the hottest month ever recorded. And indeed, I also find that in my data. So, really, no surprise there. Now, this graph here, this one here, this is based on what I just talked about. This is basically the monthly averages per year. And again, you can see the cyan line here. This is the last cycle that just finished a few days ago. This cyan line. So for the month of June and July, it's the hottest I have on record. But it's not just there. It's also around here, so like 8 and 9. But for me, like this is not from January to December. Okay, this graph, you have to look at it at kind of an inverted graph, because month number 6 is actually like December here. And yeah, usually December and January in Japan are typically the coldest months, so that's why they're at the bottom. But you can see that even here, this must be like kind of maybe April and May, also the highest I have on record. But what really kind of pushed it, I think, is June and July, because before that, the graph was kind of even, but when June and July came along, it really kind of pushed the graph up, unfortunately. So this is the per month, and I also do per year. Now this graph here, this is a per year average. And again, you can go back 7 years. You can see that it actually dropped, but that's okay. That's normal. Usually, if you look at these graphs, they always look like that. It's always up and down. It's kind of like a kind of cartoon, evil character teeth, if you want. It's very like pointy, it goes up and down. But what you have to understand here is that the overall trend, the trend line, is going up. So, yeah, it goes up and down every year, sure. But if you draw a trend line, the trend line goes up. And that's the black line you see right here. So in 7 years, we went from, this is in Celsius, by the way, because I don't know, I don't do Fahrenheit. I have no idea what Fahrenheit means, to be honest. So we went from 16.9 more or less 7 years ago to almost 17.6 this year. So in 7 years, you can say that we gained point, what is it, point 0.7, right? Yeah, 0.7 degrees Celsius. And if you read the IPCC report and stuff like that, what they mention often is that we're going to reach 1.5 degrees Celsius by about 2030. That's why they're kind of panicking about that, because it's a very rapid rate of change. Now, a lot of things, I always give this example because it's a great example. I haven't heard yet a kind of better one. Consider that a temperature of a human being, when the human is healthy, usually it's about 36.6 or 36.7 even. That's considered healthy, no fever, just fine. But if you go to 37, which is not that far, let's be honest there, it's only like zero point 0.4 or zero point 0.3 degrees difference, then that person has a fever and can actually feel very, very miserable. I mean, I've had 37 and I felt like shit. And of course, if you go higher, then it's even worse. But even at 37, you can feel very miserable indeed. And it's exactly the same with climate temperatures. even those small differences can have a very dramatic effect. Forget people for a second. We have other things to worry about in the world. We have to worry about the ocean temperatures. We have to worry about, just the land temperature in general, for the vegetation, um, for things like humidity or like, yeah, droughts or wildfires. Of course, we have to worry about the animals. Maybe for humans, we have, if we're hot, we can put an air conditioner in the room. And I'm not like advocating necessarily for air conditioning, but it's going to keep us cool. You know what I mean? Well, animals don't have that. They don't have that luxury. So if it gets hotter, maybe they already are at their limit. So if you add like zero point 0.5 degrees or 1 degree on top of that, they're just not going to survive because they already reached like their limit. It's the same for humans actually. Humans also have a limit. We have a limit to our temperature. If it's too hot, there's only so much time we can spend outside before basically we can die. And it's the same for wildlife out there. And we have to not worry just about humans, we have to worry about everything that's happening in the planet, the fish in the water, the animals on land, etc., etc. Because, like it or not, it's all part of a food chain. Now, the food chain is definitely real. I think nobody can argue against it. If parts of that food chain start to collapse, then eventually the whole thing collapses. It's basically like a house of cards. You remove a few cards, and the whole thing just comes apart. And this is what we're doing right now, unfortunately, to our planet. So this graph here is a useful, is a very good one because it can really let me see the variation per year. And you can see, in fact, that this year, I mean, actually, it was going kind of okay, but then unfortunately, June and July came along, and they were the hottest I have on record. And they really kind of pushed that whole thing up a lot. And it was definitely the hottest segment, this hottest cycle, I should say, I have measured so far. And that's very worrying. And yeah, this trend line is just nuts. I mean, honestly, if the variation was like point 1 or zero point 0.2 degrees, well, it's still not great, but here we have zero point 0.7 degrees in just 7 years. So basically, like, yeah, you could argue that okay, every year we add zero point 0.1 degrees. So in 10 years, if you extrapolate that to 10 years, we add 1 degree. And then yeah, if you do 15 years, then you get your 1.5 degrees that was mentioned in the IPCC reports and other reports as well. That's how you get that number. Not that difficult. Okay, and finally, this graph here, what you're looking at here is the daily temperatures. That's why it's a bit chaotic because, yeah, there's a lot of data points. Here it's about 7 years worth of data points, and they kind of overlap often, and it's a bit hard to make heads or tails of it. Uh, but this graph is useful because there's one thing you can do with it, for example, and that is you can calculate the amount of very hot days if you wanted to. What I mean is, first you have to define what you mean by hot day. And for example, if I say, well, all right, it's a day when the temperature is over 30. So again, it's at night, but over 30 at night is kind of extreme, really, if you ask me. And yeah, you can just go ahead and read from this graph the data points. So, for example, if I take the yellow graph, which the yellow graph is 6 years ago, you can see that actually it doesn't reach here 30, obviously not here, it's much lower, but here there's one small peak when it actually goes over 30. So you can go ahead and count how many days that is. It's probably like 1, 2, 3, I would say probably 4 days, maybe 5 maximum, but it looks like 4. And you can compare it to, for example, okay, the last cycle, which is cyan, the cyan line, and you can see already we have already many more over 30. So it is clear that if you're just using this metric, like how many days, how many hot days are there, and by hot days you mean over 30, well, you can say that definitely, this year has been hotter than before. You just have to read the chart. That's all you have to do. So there's really not, it's not like rocket science. And again, I didn't start with the conclusion, okay? I'm not one of those people. Um, I just kind of measured it as a neutral. I just said, let's see what happens. And of course, I know the theory, I know the predictions. I've seen them over and over again. And I do read articles often about the topic. I do listen to lectures. I take occasional courses online. So I'm very well versed in the topic. Like, I know what's going on. But I wanted to kind of check it out for myself. There are maybe certain places in the world which are not so great to do this kind of experiment. But in Japan, it's good because in some parts here, I already saw the predicted warming, so I wanted to check out if those predictions are actually real, and that's why I did this. Okay, so yeah, I already did a video about this before. You can refer to it if you want. I will attach it at the end of this video. But I just wanted to kind of make my summary here on this last cycle that for me ended just basically like 1 or 2 days ago. And that's it. That's it for this video. So yeah, if you have any questions on my graphs here or my data, feel free to ask in the comments or YouTube or Facebook. Both is okay. I read both, so no problem. And yeah, I will post links to my course. Check out the course. You'll learn a lot of things, honestly. Like it's I pay homage to a lot of great scientists and characters in history. So do check it out. You have a lot of fun and you'll learn a lot of things, definitely. For sure. And go in it with an open mind. Don't go in there thinking that you know everything or that this is all just a hoax. It's Chinese liberal hoax or something. Again, I will refer to this because in America people say that this is the muzzle of the devil. Not kidding. So if this is kind of the level of the average science literacy, then I'm not very hopeful, to be honest. But just go in there with an open mind and just listen to what I present, the arguments I present, and then you can go ahead and do your own research if you want. Don't just take what I say at face value. Go ahead and check it out. I already did my work, though. I already did my research when I did the course, but go ahead and double check the information. And apart from that, yeah, I will post a few articles. I mean, I do bookmark a lot of articles, so I will post some of them this month. And yeah, that's gonna be most of August, I think. So thanks for watching. And again, if you have any questions, leave them in the comments. I'll check them later. All right, JC signing off. Peace.